I'm going to deal with a couple of problems from the 4.3 packet, which have to do with distance, rate, and time. These are the type of problems where you're going upstream or downstream, or you're going with the wind or against the wind. You're fighting a current, you're being helped by a current. So let's take a look at numbers 35 and 36. I'm going to ask you to read these two problems and see if you can do some setup before I go through them. So number 35, a motorboat took 3 hours to make a downstream trip with a 6 mile per hour current. The return trip against the same current took 5 hours. Find the speed of the boat in still water. That last statement is telling you what the problem is asking you to figure out. But both of these are essentially a distance equals rate times time problem. So please bear that in mind, that distance equals rate times time, as you are working out your setup. So pause the video and please do the setup at least for number 35 right now. Okay, assuming you're back from doing your setup, here is how I would approach this. So we have the motorboat's taking 3 hours to go downstream, and it's getting helped by a 6 mile per hour current. It's also taking 5 hours to go upstream against that current. Makes some sense that it would take longer to go upstream than it does to go downstream. We also know that we don't know the distance, and we don't know our still water time, our still water speed. So I'm going to create a downstream equation with this 3 hours for the downstream trip, and I'm also going to use the 6 mile per hour current in my equation. So here is my downstream equation. So I'm going to create a downstream equation. So I don't know my distance, so I'm just going to call it D for distance. I know my current is 6 miles per hour, but I don't know my rate without the current. Going downstream, though, I'm going to add the current, and it's going to take me a time of 3 hours. So distance equals rate, which is R plus 6, because the current is helping me, times 3. Now going upstream, I'm going to have distance equals, it's going to be rate again, but it's minus 6. And then I go back and remind myself it took 5 hours, so that's my time part of my distance equals rate times time equation. So now I have a setup that I can work with two different equations, and I can solve this system. Go ahead and try and do a setup for number 36 now, which is a very similar type of problem, and see if you can figure that one out. Pause the video and give it a try. All right, assuming you have paused and you've come back with some sort of plan for setup, or you were stuck and you need some help, here's my approach. So we have this canoeist. They're paddling 4 hours, so that's a time, with the current. That means they're going downstream. The current is helping them. And then they go back upstream. It takes them 10 hours to go upstream. We want to find the speed of the canoe in still water. So it's probably clear to you again, we don't know our distance. We just know it's the same. It's going to the campsite, and return trip means that it is the same distance going back. So we can set up a downstream and an upstream equation here. My downstream equation for number 36 is going to once again be a D equals RT type of problem. Distance equals rate times time. Only my rate is a combined rate. It's rate plus the 6 kilometers per hour again, and this time it's kilometers per hour. And my time going downstream was 4 hours. All right. Now I have an upstream equation. I'm just going to copy this because I'm going to change some numbers in it, but it's going to be the same structure. It's not going to be 4. It's not going to be plus 6 because I'm going upstream. I've got to subtract the speed of the river that I'm going on. And it took me 10 hours. That is my time for this trip going upstream. So 10 hours. Now I have a setup for my downstream and my upstream. And I can use the systems of equations tools to figure out what my rate is. I can also figure out how long my trip was. The problem doesn't ask me how long my trip is in either one of these, so I can even solve these without worrying about that. But you know on the test I'm going to ask you the distance too, or I might give you two rates that are unknown, in which case 6 might be the current variable or something like that. So pause the video and see if you can solve these two problems. And then when you come back from pausing, I will walk through solving them myself. Okay, assuming you're back, I'm going to go ahead and solve these. So I'm going to copy them both. I'm going to copy this down here and this one also. Okay, so I've got my two equations. Now, d equals d. So it's the same distance either way. So I can actually do this. I can replace d with this because they both have to equal the same distance. Rate times time is an expression of distance. Now my next step is to distribute the 3. Oh, I'm going to multiply 3 times everything here on the left. So 3r plus 3 times 6 is 18. And that's going to equal, I'm going to distribute the 5 over here, 5r, and then 5 times negative 6 is negative 30. So I've got 3r plus 18 equals 5r minus 30. R, again, is the speed in still water. So let's systematically start sorting things out. I'm going to get all my variables on one side and all my numbers on the other side. I'm going to get rid of 3r on this side by subtracting 3r. Minus 3r here. Now I'll be left with 18 equals 2r minus 30. Then I'm going to try and get my numbers on both sides. I'm going to get rid of negative 30 by adding 30 to both sides. So plus 30, plus 30. And I've got 48 equals 2r. I'm going to divide both sides by 2 because both sides are twice as big as they need to be. And I'm trying to get rid of multiplication times 2. So divide by 2, divide by 2. And I get 48 divided by 2 is 24 equals r. So my rate in still water is 24 miles per hour in this case. I'm going to go ahead and work out what my distance is. So if I plug in 24 in either one of these equations, so d for my rate, d equals 24 plus 6 times 3, that's d equals 30 times 3. You don't need the parentheses there, but I'm going to go ahead and put them, equals 90 miles. So the distance for the trip is 90 miles. I can confirm that with the other equation. D equals 24 minus 6 times 5. And so D equals 24 minus 6 is 18 times 5. 18 times 5 is 90. So it's 90 miles for the trip. 90 miles for the trip. Speed in still water is 24 miles per hour. Okay, we go to the other one. I invite you to pause the video if you haven't sorted this one out already. And if you're back from pausing, I'll go ahead and solve this one out as well. So I've got this, so you've got my downstream equation. I'm going to copy that. I've got my upstream equation. I'll copy that down here as well. D equals D. The distance is the same since it's a round trip. So I can just copy this and replace D with it because D is just an expression of rate times time. So now I'm going to simplify things. I'm going to distribute 4 on the left and 10 on the right. So I distribute 4 times r plus 6. So 4r plus 4 times 6, which is 24, equals, distribute 10 over here, 10r minus 60, because 10 times 6, 10 times negative 6 is 60. And now I'm going to simplify that. Well, the first thing I'm going to do is I'm going to start moving variables on one side and numbers on the other side. All right. I'm going to subtract 4r from both sides. And I'll end up with 24 equals 10r minus 4i, which is 6r, and then still minus 60. And I'm going to add 60 to both sides. And so I've got 84 equals 6r. And I divide both sides now by 6. I'll isolate r. Because the 6r will become just r. And 84 divided by 6. Well, if you remember that 12 times 7 is 84, that means 6 times 2 times 7 is 84. So 84 divided by 6 is 14. So my rate as a canoer in still water is 14 miles per hour, which is pretty good. Now I can go back and figure out what my distance was, even though the problem didn't ask you to. You know I'm going to. So let's do the downstream equation. Distance equals, our rate was 14, which we just figured out, plus our current, because we're going downstream, and it took us 4 hours. So that 14 plus 6 is going to be 20, and then 4 is still 4, so 20 times 4 is 80 kilometers. I'm going to plug it in here as well. Distance equals 14 minus 6 times 10. 14 minus 6 is 8 times 10 is also 80. So it's 80 kilometers, and we're going 14 kilometers per hour in still water. And that's the answer for this problem. Okay, I hope that was helpful to you, and thank you for watching.